This is NASA's James Webb Space Telescope's view of Planetary Nebula NGC 6072 in the near-infrared, shows a complex scene of multiple outflows expanding out at different angles from a dying star at the centre of the scene. In this image, the red areas represent cool molecular gas, for example, molecular hydrogen.
Since their identification in the late 1700s, astronomers have discovered that planetary nebulae, the expanding shells of luminous gas ejected by dying low to intermediate mass stars, exhibit a diverse range of shapes and sizes. While many planetary nebulae are circular, elliptical, or bipolar in form, some defy these typical patterns. This diversity is captured in striking detail through new high-resolution images from NASA's James Webb Space Telescope. One of Webb's latest observations focuses on planetary nebula NGC 6072. Captured in both near and mid-infrared wavelengths, the nebula presents what might initially look like a chaotic mix of colors, similar to splattered paint. However, this seemingly disordered structure points to complex physical processes occurring as the central star nears the final phases of its life, shedding layers of gas and dust and losing up to 80% of its total mass. Astronomers are leveraging Webb's capabilities to explore such planetary nebulae, aiming to better understand stellar evolution and the broader influence stars have on their cosmic surroundings. Looking closely at the image taken by Webb's near-infrared camera, it becomes evident that NGC 6072 is multipolar. This means several distinct elliptical outflows are extending from the core in different directions, one stretching from roughly the 11 o'clock to 5 o'clock position, another from 1 o'clock to 7 o'clock, and possibly a third from 12 o'clock to 6 o'clock. These outflows may compress surrounding material as they expand, forming a disc-like structure oriented perpendicularly. Astronomers suggest that the evidence points to the presence of at least two stars at the center of this nebula. Specifically, a companion star appears to be interacting with the primary aging star, which had already begun discarding its outer gas and dust layers. The nebula's core glows with the intense heat of the exposed stellar core, which shows as a light blue color in near-infrared imagery. In contrast, dark orange areas composed of gas and dust trace paths through darker blue regions, openings or voids within the nebula. This uneven, clumpy structure could be the result of dense molecular clouds that formed in shielded zones, protected from the star's intense radiation. Time may also play a role. Over thousands of years, fast-moving inner winds could have swept through and reshaped the outer halo formed during the star's initial mass loss phase.
In this image, you can see the mid-infrared view of planetary nebula NGC 6072 from NASA's James Webb Space Telescope, show expanding circular shells around the outflows from the dying central star. In this image, the blue represents cool molecular gas, seen in red in the image from Webb's near-infrared camera due to color mapping.
In mid-infrared images from Webb's MIRI, mid-infrared instrument, the focus shifts to cooler dust components. These wavelengths reveal the likely central star, visible as a small pinkish-white point of light. The MIRI data also unveils a series of concentric rings radiating from the center, the most distinct lying just beyond the edges of the lobes. These rings could serve as further evidence of a hidden companion star. As this second star orbits the main one, it may have sculpted the surrounding material into a bullseye-like pattern. Each ring formed as the primary star expelled gas in earlier stages. Alternatively, the rings might represent periodic pulsations, where gas or dust was released evenly in all directions, at intervals spanning thousands of years. In these observations, red regions seen with NIRCam and blue areas captured by MIRI both trace cooler molecular gases, likely molecular hydrogen, while the central regions highlight hot, ionized gas. As the central star continues to cool and dim, the nebula will gradually fade away, merging with the interstellar medium. In doing so, it enriches space with heavier elements, which go on to form new stars and planetary systems. Webb's imaging of NGC 6072 provides valuable insights into how complexly shaped planetary nebulae contribute to this cosmic recycling process. If you like to know about latest information and discoveries like this, subscribe our channel.